So hey guys, welcome back. So we had a bit of video yesterday where I talked about the theory concerning the 2024 WAEC titration. So today I want to quickly run through the experiments in a short time. All the things I talked about yesterday, that you're going to have a purple KMNO4. So this is your KMNO4. You can see have a Chapman. So this is your KMNO4 and this is the FeSO4, freshly prepared. And we have the H2SO4 here to stabilize the concentration, like I said yesterday. So we're going to run through the experiment. I told you that your KMNO4 is going to be in your burettes and you're going to pipette. That is your FeSO4. But your FeSO4, the pipette you're going to be using depends on what your school is using. So if you can see my pipette, it is 25 mil. So your school might be using 20 mil, but I'm using 25 mil for my experiment. So what I'm going to do is I'm going to pipette 25 mil into my conical flask. Then I will acidify the 25 mil. Then I start titrating. Now, what you are going to notice is that the purple color of the KMNO4 will change from purple to colorless. Then after the little drops, it will change to light pink. So when you have seen the light pink, that means you have gotten to the end of the reaction. So let's go. So the first thing to do is to pipette. You know how to use your suction pipette. If your school does not have it, probably you're going to use your mouth. I'm sorry. So this is the pipette. You let out air from this end, then you press from this end to bring the liquid up the pipette. So that keeps going. So you can let the liquid out pressing this side, because I didn't mix it up together, so I want to do that again. So you can see on the right side, you let the liquid out. Then when you want to pipette, so I'm trying to mix it up together. Then you let air out on this part. Then you press this part for the liquid to come up. That's if you have it in your school, so you can use it that way, in case you have not used it before. So I'm trying to check at 25 mil. This is not Chinese, don't mind my posture, just trying to see the line. So you put it in the conical, so the hair. So that's it. Then that is acidified. So let's acidify that. So I'm going to just take 10 mil of my H2SO4, depending on what the question or your school is using. So but I'm just using 10 mil to run this experiment. So 10 mil of the H2SO4. So that's 10 mil mixed with this. So that stabilizes the concentration. Then cheers. So you release my KMNO4, it's at the 0 point mark. So, and you understand what that means. So when you are tabulating your results, first is, what is the volume of pipette I've used? So the volume of pipette used, that is 25.00 mil. So that's the volume of FeSO4 I've used. Then on my table, I'm going to have the burette reading. So the burette reading, the unit is in centimeter cube. Don't forget the unit. Then you have your table, use your ruler. So then you have your final burette reading. Followed by your initial burette reading. You don't need to add units again since the unit is here. Then the volume of KMNO4, or the volume of A used at the end. So rule rule. So the first one, I'm taking my first one as the rough titer. So the rough also in centimeter cube. So I'm going to take the rough titer, the first titer, also in centimeter cube. I'm going to do this 3 times. So then the final titer, so the third, also in centimeter cube. So that's what I have. It's because I'm not trying to waste time. So when you are doing it on your book, make sure you use ruler and avoid cancellation. So now I'm starting the KMNO4 from the 0 point mark. And starting from the 0 point mark, what did I tell you in the previous video? Make sure you put it in 2 decimal places. So now let's start. Remember, I already have my A2SO4 and my FeSO4 present. So let's dispense. So when you continue to dispense, you try to watch the color change and you try to be careful at a point where you notice the purple color is taking time to disappear. So at that point in time, you drop it drop by drop. So you can see as I'm adding, the purple color is changing to colorless. This means that the KMNO4 is reacting with the Fe2 plus. So you can see there's a bit of light pink. So you can just drop a single drop. That shows something else. So try and be consistent with your color. This is light pink, but I want to do a shade just to show you a bit of color. So you can see, so this is light pink. So try to make sure you are consistent. So my next one must have this same color. It shouldn't be lighter than this and it shouldn't be deeper. So this light pink is my end point. So let's read the values. So from what I have here, I don't know, maybe I took too much time. So this is 8.5678. So you always take your reading at the top. So this is 8 point, that's my rough. So that's 8.80. So meaning that I've used 8.80 volume of KMNO4. So you can refill, but I'm not going to refill it. Let me refill it in order not to waste time on the calculation. So I can start from zeros again. So I want to start from 0 again. I need a single drop to fill it to 0 to avoid some bit of error. Okay. So that's my KMNO4. So just trying to rinse the conical flask, then we go again. So what did I say you are going to do? So I'm going to pipette just 25 ml of my FeSO4. So let's go. Let out the air. So then so that's 25 ml. So quickly you do that for 3 titers. So how many mils of the acid did I add the other time? That's 10 ml. So I want to do the same thing. Okay. So this can be my real first titration, so avoid any form of error. So let's go again. I left the other one for so long and shouldn't be like that. So you can see it has changed to colorless. So let's go dropwise. It's almost going to change to pink. So then you keep dropping. That's that. So I want it to have almost the same color as it had before. So this is my light pink. So you can see that. And now there's a bit of discrepancy here, and I know why that happened. So this is at 11 mark, so that's 11.00. So I had to refill. So this is still allowed because there was an error here, so that would be 11.00. So let's go again. So I want to refill it back to 0. So it makes my maths easier, that's all. So you can continue from 11, then if it gets to 22, then you know you already have another 11. So sometimes this can waste a whole lot of your chemicals. So it's better you continue to use it the way it is. And this can also waste time. So what do you want to save? You want to save time. So let's have my 25 mil again. That's 25 mil FeS04. I'm trying to be fast because of time. So avoid the spillage when you're having yours. So that's 25 mil. So let's go again. Starting from 0, I noticed something, but let's see what we have. That was much. That's a bit deeper than what I used to have. But you see, when I wanted to release the FeSO4, I sucked up these two, which means that a part of it might have been trapped here. Let's see. Can you see? So by mistake. So now what I have here is around 10.8. 10.8. And if you're taking 10.8 out of this, it's still fine. But the issue there is that the parts that didn't react, maybe this could have gotten to 11 directly and it would have been an accurate experiment, but I just had to let it go to continue the experiment. So avoid such errors. So this is 0.00 and this is 10.80. I think that's around 0.2, so it's still okay to have that. So let's go for the final titration quickly. So here I'm going to refill again. I have some students waiting to use the rest to play, so we'll give them. Normally when you are titrating, you do not leave your funnel. You do not leave your funnel because the part that is dropping can add errors to your experiment. So, but just to show you what I'm doing within a short time, and you know it's KMNO4, the color can be strange to see on that line. Okay, so you are supposed to remove it and drop it because any single drop will add to the volume of KMNO4 you are using. So you go again, let go air to avoid this error. Let go of anything that is inside here. So it should be air, not liquid. So I've trapped some liquid inside, that's why liquid is coming out. So now I'm going to avoid that error again. So you press this to let the liquid come up itself. See, I don't know how air is trapped in this thing. So that's it. So to keep it at the exact volume, let go. So that's that. So I made a mistake pressing this, then sucking it inside instead of pressing this to just release it. So that was the mistake. So avoid such mistake. I know maybe you are going to use your own mouth, so you might be the one to suck it in your mouth. So but if you are using a pipette filler, avoid such error. So let's see what we have. So acidify. So I'm adding just 10 ml. So the concentration of FeSO4 that I dissolved and KMNO4 can be determined from our experiment. So let's see the final round and see how it goes and see if our result is going to be accurate. When you're doing the right thing, you will know, because your results should be close. That's accuracy. Should be very close to the true value. So you can see. So I like to see my color a bit. This is still Ojukokoro one more time. So that's the light pink. So let's see what I have. So perfect. This is still like 10.7. So I don't know what could have caused that, but that's 10.7. We're not going to cheat. So I started from 00, then this gave me 10.80. So this is 10.70. The gap here is a bit far, but that's around 0.3. So I can calculate my volume of acid used now, or volume of KMNO4. So average theta value. So how do we calculate the average theta value? So we say we're going to use our first theta plus the second plus the third. So can someone press calculator for me, all divided by 3? So we're going to have 11.00 plus 10.80 plus 10.70 all divided by 3. So let's see what that gives us. So you can perform some other questions on this. You remember the reaction I gave you yesterday, that's MnO4 minus plus 5 Fe2 plus 8H plus will give us Mn2 plus Fe3 plus, and I'm going to have 5 of it, plus 4H2O. So this is the equation of the reaction. So what did that give us? 10.8. So we have 10.80 centimeter cube or mu. So that's what we have as the average theta value. So you can call that the volume of A used. So I can determine the concentration of A. How do I determine the concentration of A? And so the final answer is 10.83 cm cube. So how do I determine the concentration of A? I can use my Ca Va over Cb Vb, and that will give me Na over Nb. And what is my Ca? That's what I want to determine. My Va is going to be the volume of KMnO4 that I used. Then my Na is going to be the number of mole of KMnO4. Then the concentration of B can be determined. Maybe it would have been given in your question. Or you can also use this formula that says that concentration in mole per dm cube is equal to concentration in gram per dm cube all over molar mass. So meaning that we are going to be given the concentration of iron in gram per dm cube. The mass you dissolved in a particular volume, you are going to be given. Then you calculate the concentration in mole per dm cube. Then you bring it to this formula. Every other thing depends on your experience in stoichiometry. So when you have your CB, you remember your VB. That was the volume you pipetted, 25 mil. So you're going to use that 25 mil multiplied, and from there you can find your Ca. So every basic calculations you need to do will depend on what your question posed on the day of your exam. So this is how the experiment is done. Don't forget, be careful in the laboratory. Be careful with most of the chemicals you play with. And that's why most chemicals are labeled in the laboratory. Be careful not to touch concentrated H2SO4. That can be corrosive and that can destroy many things as well. So that's all for quantitative analysis. Please make sure you subscribe to our YouTube channel. We'll still talk about the qualitative analysis. That might be tomorrow again. So we upload the video on qualitative analysis. Now, this result I've gotten might be different from what your school will get, depending on the concentration they have used. So do not cram this answer. So what we are just trying to give you is a clue on how you are going to perform your experiment that day. So your results might be totally different from this. Make sure you know what your teacher has told you to do. And that is very important. And do not forget, during my calculation, I said I'm going to be using 25 mil here because I used a 25 mil pipette. So if your school uses 20 mil pipette, that's what you're going to use in your calculation. That's why you cannot copy whatever I've done here. We're only trying to put you through and make you understand how all of those things are done. So subscribe, click the notification button, continue to share with your friends. Let them learn from their comfort zone on how experiments are done. And God bless you all. And I'll see you in the next episode. Thank you.